Hey guys, so I've already posted many videos on limits and I broke them down separately, and in this video I'm going to show you all the kinds of examples of limits and what to basically do in each case, okay? So I hope this is going to be very easy. Now, first thing that you should always do when you are looking at limits is just do direct substitution. And if you could envision the graph, that would help as well. So in this case, I want the limit as x approaches -1 of the function 5. If you guys can think about what the function 5 looks like, it's basically a horizontal line at y equals 5, and we know it's continuous, and we know that at every single x it's 5. If you try to do direct substitution, there's no way to plug in the -1, so that's just 5. Here, this is a cubic function. I know there's no problem with the cubic function. There's no denominator, so I'm not going to have any place where it's undefined. So I'm just going to direct substitute the 2 right into the x. So that's going to be 8 minus 4, and that's going to be 0, okay? Next one, this is the square root. I know square roots have problems for numbers that are negative or that make the expression under here negative. So right now, the only thing that would make this negative would be any number under -3. Well, I care about, what the limit is as x approaches +3. So once again, direct substitution, and that's your answer, okay? Here, I'm going to try direct substitution. In the numerator, I'm going to get a -3. And in the denominator, I'm going to get 1 minus 6 plus 8. I know that this negative and this negative makes a +3. And I know 8 minus 6 is 2. 2 plus 1 makes 3. So this whole thing is just 1. And I know what the graph sine x looks like. It looks like this. It's also continuous. There's no fraction that would mess it up. So I just have to plug in pi. Sine of 180 degrees, or sine of pi, is 0, okay? So this is the direct substitution problem. You should always start there. Let's go on to this one. Okay, I go and I plug in. I have this function f of x. I have x squared minus 8x minus 9, x squared minus 1. I want to look at the limit as x approaches -1. When I do a direct substitution, you have to show this first. You're going to get -1 squared is 1. -8 times -1 is +8. Minus 9. 1 plus 8 minus 9 is 0 on top. -1 squared is 1. Minus 1 is 0 on the bottom. So your next thing to do is when you get 0 over 0, see if you can factor it. So I already factored this out for you guys here. You can pause the video anytime and try these problems before I do them, okay? So I factored it out to x minus 9, x plus 1, x minus 1, x plus 1. These cancel out. And then to find the limit, I have to resubstitute into what's left over. So -1 minus 9 is -10. -1 minus 1 is -2. And that's going to be a 5. Okay, so that's all that is. And if, for anybody who remembers, if you go to graph this, we're going to have a problem at -1 comma 5. It's just going to be a hole there. But the limit is basically what happens when you get very, very close to -1. Okay, so it starts to approach +5. And throughout any of these videos, I apologize if I make any algebraic errors, like adding something really silly or whatever. I'm just doing this all for the first time. Okay, next one. I plug in the 6 for g of x into this function. I get 6 plus 3 is 9. Square root of 9 minus 3 over 6 minus 6 is 0 over 0. So what do we do in this case? Well, obviously we can't factor it. So we are going to rationalize the numerator. So that's going to be x plus 3 plus 3. We never change the guy that's under here. It's just this guy, which is the conjugate, okay? Square root of x plus 3 plus 3. And then when you go to basically FOIL or distribute, you're going to take this guy here and multiply him with him. You're going to, do you guys remember how to multiply conjugates really quickly? It's just going to be square that guy, which is x plus 3, always a minus, okay? And then 3 squared is 9. The numerator gives you x minus 6. The denominator, never distribute this. All you do is put that side by side, okay? So that looks like this. And so you're going to, that's why we don't distribute this, because you're going to notice that something cancels out. And that's this guy with this guy, leaving you with a 1. Resubstitute your 6 into the denominator. 6 plus 3 is 9. Square root of 9 is 3. 3 plus 3 is 6. Your limit is 1/6. So in these two examples, I noticed that the limit as x approaches the value gave us 0 over 0. So you either factor, you rationalize, and here's the third one. Or we are going to crisscross tomato sauce in this. All right, let's take a look. F of x is equal to 1 over 2 plus x minus 1/2 over x. The limit as x approaches 0. When you plug in 0, you get 0 over 0. So what should you do? If you guys remember my crisscross tomato sauce video, I'm going to combine fractions really, really fast. I'm going to go criss, 1 times 2 is 2. Cross, -1 times 2 plus x. Be careful, okay? So -1 times 2 over tomato sauce. 2 times 2 plus x. All of that is divided by this guy. Dividing by this guy just puts him really over here. You guys can do your keep, change, flip stuff. All right, let's get rid of some stuff. 2 minus 2 is 0. They're gone. You're left with a -x over 2 times 2 plus x times x. You still have to cancel, otherwise you're going to get 0 over 0 again. X over x leaves you with a -1 in the numerator. Now you're done canceling. Plug in your 0. 2 plus 0, 2 times 2 is 4. And you get -1/4. All right. Those are your 3 types that you would get 0 over 0. There's other things that you can do, but for as far as rational expressions go, those are the 3. All right, here's a piecewise defined function. I don't know why I just did that. Okay, I need my highlighter. This says for any x value that's less than 1, use x squared. So you guys know that's a parabola. Any x value that's greater than 1, use x. We know that's a line, okay? The only issue that you have to consider as a possible point of discontinuity, which I will talk about in later videos, is this guy right here at 1. So in my first example, I only ask you what's the limit as x approaches 0. I have no problem at 0. So what I'm going to do is I'm going to say, hey, if x is less than 1, which it is in this case, I'm going to use him. So put 0 in there, and you get 0 squared is 0. Done. How about here? I'm going to start with this guy first, actually. What about the limit as x approaches 2? Well, for guys who are bigger than 1, you're going to put it in here. So that's just 2. Finally, the limit as x approaches 1. Well, let's see what happens with when I put 1 from the left. Do you guys remember that? That means a little bit less. That's going to be 1 squared, which is 1. Limit as x approaches 1 from the right. Well, that's this guy. That's just 1. Since they both go to the same place, this limit would be 1. Great. I think I'm going to stop here, and we're going to do more examples in the next video. The next video, I'm going to do infinity, and I'm going to do the trigs that we just learned in the last 2 videos. Okay? Have a great day.